Suppose I'd like to graph this equation. Well, if my equation is in standard form, I can graph it using intercepts. This looks similar to standard form, although we have an x term here and our y term is over here. So in order to put it in standard form, I'm going to need to do a little rearranging. If I add 12 to both sides, I get 3x, this cancels out, equals 4y plus 12. So we're getting a little bit closer, but I still need to have my x and y on the same side of the equation. So I'm going to subtract 4y from each side of the equation, leaving me with 3x minus 4y is equal to 12. Now I have something which is clearly in standard form. I have a positive integer coefficient for x, an integer coefficient for y, and it's the form ax plus by equals c. So, because it's a linear equation, I can graph it by finding its intercepts. You'll recall that the x-intercept is where the equation crosses the x-axis when y is equal to 0. So to find that, I'm going to set y equal to 0. The x-intercept is the solution to 3x minus 4 times 0 equals 12, or simply 3x equals 12. In other words, the x-intercept is equal to 4, because when y is 0, x must equal 4. Similarly, I'm going to find my y-intercept by letting x equal 0. So the x term cancels out, and I'm left with minus 4y, or negative 4y, is equal to 12, in which case y would have to be negative 3, and we have a y-intercept of negative 3. What that means is that my equation is going to cross the x-axis when x is equal to 4. It's going to cross the x-axis at 4, and it's going to cross the y-axis at negative 3. So I can go ahead and graph those points. My x-intercept and my y-intercept. Now all that remains is to connect them. It's a little hard to draw a straight line here, but I shall do my best. And there we have it. That's our graph of the solution set of our original equation, 3x minus 12 equals 4y. And we graphed it using intercepts, in other words, by finding the value of x when y is 0, and the values of y when x equals 0. Thank you very much.